Hey, good morning, everyone. I'm soon gonna start. Give me a few seconds. Okay, so I should be fine now. I am just going to change the scene. Hey, yeah, so today I have to admit this past week I was a bit annoyed by, well, the Scala world. So I decided to give a try to Swift, and so far I did some Swift a few years back, and I really did enjoy it. However, I haven't been able to practice, so I completely forgot everything about it. I barely don't even remember how to do a Hello World kind of stuff. So today I wanted to give it a try and try to get Swift installed on this Windows machine. I found some tutorial on Medium that I'm going to use, and then if that works, then I guess I will be relearning everything about Swift. Especially, I'm very interested in everything that has to do with concurrency, which is which is one of the things I really enjoy the most about programming. And once and if I manage to get things running, I am going to investigate to use certain libraries, such as I've heard about Vapor, which apparently is the way to go if you want to do some server-side development in Swift. And who knows, maybe because I've started to work with Scala and create some kind of a Twitch bot. Maybe we can create a Twitch bot in Swift in the end. So yeah, that's what I'm gonna do today. Really, the goal for me, the main goal is to get things running on this Windows machine, so that at least I can get an idea. If that doesn't work, then well, I've got a Mac as well in the background here, so that's I can always use this one. And yeah, that's gonna be it. All right, so let me share my screen, and this here, this Medium post is what I'm going to use as my. That seems super easy. I mean, apparently there are just two files for us to modify, and we can run everything from Docker. So that is super interesting. I'm just going to post this one, the short link to Discord. So give me 1 second. I'm going to do that. And where is it? There we are. So programming, and I'm gonna put this thing here. Oopsie. So is it working? No, it's not. Because yeah, well, of course, it is the beginning of the stream. Well, it is a stream for me. So never seems to be working the first time. You know, still discovering the whole thing, right? Okay. So here, basically, we are going to be using the Visual Studio Code remote extension, and we will need to install, there is this extension SourceKit LSP. So LSP is Language Server Protocol, I think that means, and code LLDB. So LLDB is for debugging purposes. Basically, we can put some breakpoints here and there to see what is going on in there. So VS Code Remote is an extension you can install into VS Code. So I think I already have it. And once installed, if your project contains a .dev container directory, VS Code will give you the option of running your project in remote mode. All right. Okay, so here, I guess that what I need to do is I need to create this .dev container directory. All right. So here I've got my WSL window open, and I'm going to use this one to connect. So I have this on the theme folder, work, funky functor, and I think I created something for, nope. What do I have here? Swift. So cd Swift, that's good, and there is apparently nothing in here, so I am going to create a new folder, mkdir stream, let's call it that way. Okay, good. So let's go into stream, and then they mention a project contains a .dev container directory. Okay, so we are going to do that. Okay, so here mkdir, and let's paste the .dev container. All right, so I've got my .dev container. Okay. In remote mode, we'll talk to a remote Docker container which runs a VS Code server. That is good. So what should you put in your dev container directory? Two files are required, dev container.json and Docker file. All right, so here is an example dev container.json. All right, so let's do that. Let's create this dev container.json. So let's go here. I'm going to do a VI and then paste the name. And we are going to copy the whole thing. So let's do that. Copy this. Perfect. And now I'm going to get into insert mode. Paste everything. Ooh, that is ugly. That is really ugly. However, that is a JSON, so that should be all right, I guess. We'll see. We'll see. So if that doesn't work, then I can always try to reformat. Okay, so I've got this VI dev container. So in here, I've got the name here. So that's Swift. Okay. The Docker file is Docker file. So okay, that seems to always be that. We can expose ports. So right now, that's not what I'm going to do. Run args is the arguments that VS Code should pass to the Docker run when it runs your container. In the case of Swift, we need to give the container some elevated privileges so that LLDB can use the ptrace system call. Alright, so okay, that's the ptrace thing that they're talking about, and the elevated security is this, so we unconfine the security. Okay, that makes me a bit nervous when we need to increase this kind of stuff. Okay, and then we've got extensions. So extensions from the VS Code marketplace that should be installed in the VS Code server in the container. So we install source LSP, which is, okay, so we've got this pvasec source kit. Okay, all right, why not? And code LDB, so that is being used for debugging. Okay, so far so good. All right, and settings. So configuration options for the VS Code extension you are installing. In this case, code LLDB needs to be told where to find LLDB. And we also teach VS Code how to run a shell inside the container. So LLDB is bundled, that is part of it. The executable is located in here. And this here is the, okay, link to bash. I mean, that makes sense. And here, so they say from Swift 5.1. I'm not interested in Swift 5.1. I think the latest version of Swift is actually 5.5. Let's have a look. Swift.org. Welcome to Swift. Download, and it probably mentioned, so yeah, the latest version is 5.5.1. So what I'm going to do is I'm just going to replace the version oopsie. So I am just going to replace the version from 5.1. I'm not interested in 5.1 and put latest instead. That should be fine. Okay, and so that is, this one needs to go into a new file called Docker file. So let's do that. vi docker file. so let's paste the whole thing, and it's, as we said, I want to use latest. Okay, so let's take a look. I should have two folders, two files. All right, I've got Docker file and dev container.json, and they are in dev container. Okay, so now launching. Once you've installed the VS Code remote containers extension, when you open up a project that contains a dev container directory, VS Code prompts you to reopen your projects using the container. Alright, so we'll give it a try. So VS Code is here. I'm launching it. Of course, it opened on a different thing. Alright, so I am going to click on Open Folder, and my folder is on the Work, Funky Functor, Swift, and Stream. So let's open this one. Do you trust the... Yeah, because I was the one who created it. In the parent folder, yeah. And okay, they say folder contains a dev container configuration. File reopen folder to... Okay, let's do... Where did it go? What happened? Oh, there's a restart to update. Let's try that again. Maybe I haven't opened VS Code in such a long time that... Okay, that would be nice if you could reopen VS Code. So I have this thing here, reopen in container. Let's click that. Oh, and apparently my Docker daemon is not running. Okay, let's see. Indeed, I don't see it running, so I'm gonna... You can't really see it, but I will run it. I will be running it on my machine. So Docker desktop. It is starting, I think. I must have restarted my machine because I know I used Docker yesterday. So Docker engine waiting. So it must be starting now. Let's wait. Waiting. Okay. It is taking its sweet time. Alright, so that seems to be working fine. And, well, quick disclaimer, but I think this will be very obvious. I am not familiar with VS Code, so I don't use it very often. So we'll see how it goes. Alright, so should I close or reload? Do I have an option to reload stuff? No. Or I think, what is that now? So we've got new whistle reopening container. That seems interesting. Remote containers. Okay, let's try that. Starting dev container, building image. That's good. Let's click on the show log. And we're going to make this guy bigger. That seems to be working. A lot of things are happening. Installing extensions. That is good. I like that. Acquiring code LDB. Yeah. Cool. Okay. That's... I don't have any errors, I guess. Okay. Good. So let's try create a new file. So main.swift, I guess. Okay. Let's go and look for a hello world kind of let's do that. Swift hello world, yay. Okay. Okay, so I can just put a print hello world. That sounds good. All right, so I'm gonna do that. Where is VS Code? Okay, so in my main, I'm gonna click on paste. Okay, and how do I run that? Do they mention it in the tutorial? Okay, no, they don't mention that. All right. Can I open like a, well, is this terminal, can I put stuff in the terminal? No, I can't. Okay. And okay, there is a run, start running, start debugging, or run without debugging, Control F5. That's interesting. So I want to run it, I have no idea, not Chrome, that's not a Chrome or Edge, that's not a Node.js. LLDB, I think, is if I want to troubleshoot stuff. Well, let's try LLDB. Can it start debugging because no launch configuration has been provided? Okay, not what I wanted to. Let's try run without debugging. Unable to find executable for workspaces, stream your program. Okay. So how do I run that? That is, okay, there is nothing in here. Okay, advent of code in Swift. Now, let's do another research then. So run Swift from VS Code. Let's try that. How to run? Yay! Well, that's a YouTube video. Swift of VS Code. What is this one? Okay, nope. Nope, that's not what I wanted to. What was the name again of the? So we are using the source kit LSP. Source kit dash LSP. Let's see. Okay, there is this thing here. Good. Install Xcode. Okay, install Visual Studio. Install Node. Okay, well, we probably have everything, and they don't mention how to run that. Okay, okay. So maybe in getting started in Swift, there is something about on macOS, on Linux. Okay, we need to install all of these. We can even have that running on Windows. That is interesting. Enabling developer mode. No. Swift version. So you can verify that you are running the expected Swift version of Swift by entering the Swift command. So can I? Yeah, okay, so I'm gonna try a new, okay. So workspaces stream, let's do Swift dash dash version, I think that was the one. So I am running Swift version 551, okay. Let's see now, can I? So I can use the REPL, that is good. Okay, yeah. I can do some imports on Windows, okay. Using the package manager. The Swift package manager provides a convention-based system for building libraries and executables. So that is good, but not yet what I want to do. Creating a package. To create a new Swift package, first create an enter directory named hello. Okay. Every package package must have a manifest called package.swift. And then here I've got these. You can create a minimal package called named hello using Swift package in it. Okay, let's try that then. So I am gonna go here, Swift package init, and this is called tests. No, is it? So I have here my, okay, that's called stream because, well, I guess that is because I am in the stream folder. Okay, sources, I've got the stream.swift and I've got hello world. All right. So public init. Okay. And test. Okay, so I can also have some tests as well. That is interesting. All right, so by default, the init command, and then I can click on Swift build. Okay, let's try that. So here I'm going to do Swift build. So fingers crossed, everything should be working. It is working, yay! That is nice because it really loads very quickly. Build complete. Okay, then I can run my test by doing Swift tests. All right, let's try that. So Swift tests. It seems to be running again. Okay. Let's try wrapping. Okay, 7. So everything is getting loaded. And the test completed. So the tests are working. I wonder how that works, but I guess this is something I will discover later. Okay, and now building an executable. So what did I, oh, I created a package before. Okay, and now I need to explicitly indicate that I want to create a type executable. And then I can run Swift run command to build and run the executable. Okay, so I am going to try that again. I probably will need to delete what I did so far. Let's try without deleting first. So Swift package init type executable. Our manifest file already exists in this directory. Okay, so I need to get rid of these files. So let's get rid of package. I don't need main either, so I'm going to get rid of these guys. Try that again. And okay, so right now I've got this package.swift. That seems to be working. That hasn't changed. Okay, Swift build and you know what? Let me try to delete everything just to be on the safe side and make sure that everything gets created. So I am going to go. Where is this? Yeah. So I am going to do I'm going to delete package Swift. Okay, I am going to delete the folders. I want to get rid of sources as well as test. Hopefully they will be created as well. Okay, so let's do that. Type executable. So sources and tests have been created as well. Okay, and do they look the same or are they different? Okay, they are different. So right now I've got this print hello world and my test is, ooh, that is one long thing. So test example, this is an example of a functional test case. Mac Catalyst won't have process, but it is supported for executables. Well, that is very, very complete. Oh, I think I'm gonna have a lot of fun learning about tests on Swift. Okay, so right now it should run and print hello world. let's print hello Twitch world, just to make sure that this is what I am running right now. So based on that, I could run a swift run hello run, and that will take hello and try to run that. Since there is only one executable in this package, we can omit the executable name from the swift command. Okay. You can also compile the package by running the swift build command and then run the binary from your build directory. Okay, so that creates an executable. Interesting. Let's try that. So where is it? Swift build. So I am here. Oh, let's close that one. So they said Swift build like that. It seems to be building. Okay. And so they mentioned a build folder. Okay, so it's in .build, and then the platform I am running on, and then debug and hello. Let's try that. Okay, so I have built unknown Linux GNU and debug. Is it debug? Debug and hello. Okay. So debug and okay, that must have been stream then. Okay, let's try that. So that was in bin. Okay, why is it is autocomplete not? Oh, cd. No, I wanted to do bin and then build, not bin. So okay, so dot build and then x86 debug and stream. I think that was the name of what I wanted to do. And hello Twitch world. Yay. Look at that. That is groovy. Alright, so working with multiple source files. So create a new file in the sources hello directory called greeter.swift and enter the following code. Okay, and then I can call. So that this one is just going to print with a name, and on my main what I do is I take a look at my arguments. So command line.arguments.count. So if I have at least if I have something different than 2, so 2 arguments, I guess the first one must be the executable name and the second one must be the actual argument I am interested in. Else let name equal, so let I believe is in Swift the equivalent of a val in Scala, meaning that we have a variable with a value that gets assigned only once. So let name equal command line.argument of 1, so I am taking the first argument and then say hello name. Okay. And rather than using a hard-coded name as before, MainSwift now reads from the command line argument. And instead of invoking print directly, MainSwift now calls say hello name method. Because the method is part of the hello module, no import statement is necessary. Oh, and they do even fancy stuff with Swift run hello and who am I? Alright, so let's try that. So they want us to create a greeter.swift. Let's do it. So I'm just going to collapse the content of build. I have sources here, so in stream. And I want to create, so they said that it was called greeter.swift, like that. Cool. And I am going to copy this thing. So, okay. So let's do that and paste. So I have this hey, say hello with print hello and the name. Okay. main, instead of printing this hello Twitch world, I am going to do this if command line. Okay, so let's do that. I'm going to copy this, replace the whole thing with that. So, okay, hello, yeah, okay, that's good. And then run Swift run and try the new version of hello. All right, so let's try this. Swift run. I think for me the project was called Stream and Test. So everything, and I am still getting hello Twitch world. So that's not what I was expecting. Interesting. Let's go back. So I must be missing something. So run Swift run and try with a new version of hello. Should I maybe get rid of the build folder? Maybe because I built it, it's reusing it. So let's do that. I'm deleting the build folder just to be sure that I am not reusing the executable. And I am trying to run that. So it should force everything to be rebuilt. So I've got hello test now. Good. Let's try without the argument. And I've got usage, hello, and then we need to pass the name. Cool. Just to be on the safe side, I am going to take a look at the first argument, because I think this should be the name of this. So here I'm going to do command line dot arguments. Oh, I love the autocomplete. That's super cool. And pass 0. Hopefully, well, I could be getting some. I could get in trouble, but let's see. Swift run stream and usage. All right, so that passes the whole the whole name of the executable, and then name. Okay, that is cool. That is super cool. Okay, so what should I do now? Okay, let's relearn about Swift. So, okay, working with multiple source files using the LDB debugger. Oh, nice. So you can use the LDB debugger to run Swift programs step by step, set breakpoints, and inspect and modify program states. As an example, consider the following Swift code, which defines a factorial n function and prints the result of calling that function. So I define the function itself. So I've got here func. Oh, I like that. Factorial, then I pass n, and that returns an int. So if n is lower than 1, then I return n. Otherwise, I return n times and the factorial of the value. Okay, so we can try this. Let's copy this. I'm gonna take that. Okay, cool. No. I'm gonna create a new file. So this new file I'm going to call factorial, like this, dot Swift. I'm going to paste it. So paste. I will just need to keep the definition for factorial. So far, so good. So if and da da da. Okay, so that's exactly the same. And now in my Swift, I need to call. So this here is to say hello. Do I need that? No, I don't. So can I just, yeah, argument, and now I want to do a let result equal of factorial. Oh, it doesn't see factorial. What was the name again? That was factorial here. So let's try factor. Okay, that doesn't seem to be working. So that is the first limitation we are meeting. So factorial. Oh, and then I'm going to use for, and I want to do a print. Oopsie. Print. And on this print, I am going to display factorial of, let's even put a variable. Let value equal 4, and then I can call here factorial of value. So factorial of, and let's pass this like that, value is, and then results. And I think I need to surround it in parentheses. So let's run this guy. Maybe if I rebuild stuff. Okay, so cannot find fac in scope. Where is fac? So it is complaining in main Swift 8.14. Main Swift 8.14. Oh, probably some problems I need to save. Okay, so I saved it. Let's try to run that now. Missing argument label n. Yeah. I keep on forgetting that in Swift we need to name the values, but I could just, I think putting an underscore means that I can just avoid naming the values. So factorial here, that should work again. Let's try that. Okay, no. Oh, maybe did I forget to save? Yeah, I did. Okay, extraneous argument n in core n minus 1. So yeah, that was here. I don't need that guy again. It is very far. Dang it. I keep on forgetting to save stuff. Is there an, oh yeah, there is an autosave. Let's click on autosave. Yeah, that should go a bit faster for me. All right, let's try that. Yay! So factorial of 4 is 24. So let's see, 1 times 2, 2 times 3, 6 times 4, 24. Yeah, that makes sense. So that works. Okay, so created a file called factorial.swift with the code. Okay. This will create an executable named factorial in the current folder. So I can do a Swift C, Swift compiler, I guess, dash G. Okay, so G is for debug informations. That makes sense. And then I can do, instead of running the factorial program directly, run it through the LLDB debugger by passing it as an argument line to the LLDB command. So this will start an interactive console that allows you to run LLDB commands and set a breakpoint on line 2 of the factorial function with the breakpoint set B. Whoa. That is getting complicated. I understand why we use these IDEs now, because here just this thing here, that is exactly the same as, you know, going in IntelliJ. I guess that must be the same thing here, but I can just press here and say, hey, that's a breakpoint. So just, yeah. Okay, so here factorial use the print p command to inspect the value of the n parameter. The print command can evaluate Swift expressions as well. Wow, that is impressive. Use the backtrace command to show the frames leading to factorial so I can get my different frames. Use the continue. Okay, so everything here that is how we can do that with the command line. Okay, that is nice. That is really, really nice. So I have this thing here, main. Okay. So let's read the documentation about Swift 5.5. So about Swift features, standard library bundled as part of the language. I'm going to open it on the side. Core libraries on the side as well. That could be interesting. So Swift compiler. Yeah, I'm not really interested in the compiler itself. And here I've got Swift core libraries. So I have commonly needed types, data, URL, character set, specialized collections. Okay. Unit testing, noise, networking primitives. Okay, that is cool. Scheduling and execution of work, including threads, queues, and notifications. Oh, we like that. Then we've got persistence, including property lists, archives, JSON parsing, XML parsing. Okay, that is already out of the box. For the server side, we've got a lot of things. Support for dates, times, and calendrical calculations. Abstraction of OS-specific behavior, that might come in handy. Interaction with the file system. Internationalization, including date and number formatting and language-specific resource. And user preferences. So that is nice. So on the Swift core libraries, I can already notice that there is no mention of anything related to UI, which is not really a problem for me. I mean, I'm desperately bad at UI, so I don't think I'm gonna be using this. But it's always good to know that basically I don't think I should be able to do that. Okay, so foundation, libdispatch, so we've got the Grand Central dispatch, and then we've got XCTest. Version of XCTest uses the same API as the XCTest you are familiar with from Xcode. Okay, so this XCTest is I guess, open source version of what Apple has with Xcode, and I'm really not familiar with it. So, yeah, one of these days I should get familiar with it, but probably not right now. Right now, I'm just going to refresh my memory about this kind of stuff. Okay, so. Right. And then we've got continuous integration, source compatibility, security. Wow, that is a lot of things. Okay, so where is the documentation? Is it here? So getting started guide, Swift resource, and Swift programming language. Is this Swift defines a way large classes of common programming errors by adopting modern programming patterns. Variables are always initialized before use. Okay, that's good. Array indices are checked for out-of-bounds errors. Perfect. Integers are checked for overflow. Okay. Optionals ensure that nil values are handled explicitly. Great. Memory manage automatically. Very helpful, and error handling allows controlled recovery from unexpected failures. Okay. Okay, so yeah, language guide. So we have the basic operators. Okay, string and characters. I'm not really that interested. I think I remember a few things about these. Yeah, multi-string literals. Okay. Okay, so space is ignored. Oh, that is nice. So if we have some indentation, we can keep these indentation. Cool. Yeah, we can also use Unicode. Okay, why not? Collection types. So we've got arrays, sets, and okay, dictionaries is what me from the Java world I'm familiar with maps. So yeah. Mutability of collections, arrays. If you create oh, not cool. But it's okay. I mean, if you assign an array, a set of dictionary to a constant, that collection is immutable. And the size, okay. So that is interesting. If it is a variable, then it is mutable. If we assign it to a constant, the collection is immutable and the size and content cannot be changed. Okay. I guess I will need to work with this a bit more. So Swift array is bridged to foundations and as array class. Okay, brilliant. That I have no idea what foundation is. I guess I will discover about it later. Creating an empty array is var some ints, and I declare the type, so that is very similar to Scala. And then I just put an empty array. Okay. That is interesting. And then if I do some ints data happens, so some ints is a var, so I'm allowed to do this dot happens. I wonder if I can do. You know what? Let's try that. So I am going to okay. I'm going to command these. So as I said, var var, and the name is some ints equal of that, and I will explicitly indicate that this is an array of integers. Okay, so I've got my array of integers, and what they do is they print value. So okay, let's do that. Print, and value is, and I pass my some ints. Okay, so that should return an empty array. Now I'm going to do let, and this let means that this is immutable. So let some other ints equal. So I'm going to take some ints and do a dot append of a new element of how does it work? So append, and I can just indicate the value. Okay, so append 3 like that. Cool. So print value. So well, let's take the first one first. We want to make sure that what is the value? Some ints is, and we're going to display some ints like that, and then some other ints is, and we're going to pass some other ints. Okay, so let's try to run this guy already. Swift run stream. So, okay, so now I've got value is, so value is an empty thing. Okay, good. Then some other ints is, interesting. So some other ints is empty. Did I do a mistake? Maybe, let's see, because that's already there. That doesn't look similar to what I had here. So let's give it a type, int, like this. Okay. So cannot convert the value of type this to specify type int. Okay, so append modifies, but it returns a unit. Oh, that is interesting. Okay, so let's try that. So some ints append, so that doesn't do anything, but I can do some ints like that. And now if so I'm going to do the same thing again. So what that means here is that some ints should be equal to 3, same thing as before, and some other ints should be equal to 3. Now I'm going to append, let's say, 6, and some ints should be equal to 3, 6, but some other ints should still be similar to the previous version, since it's supposed to be mutable. So let's see, does it work? Yes, I am understanding this properly. Okay. So some int is 3, some other int is 3 for the first one, some int is 3, 6, and some other int is 3. It hasn't changed, it remains the same. I like that. Good. Okay. Give me one quick second. I am going to try. I am going to try something else. So give me one second. Okay. So I've got some ints, some other ints. All right. Creating an array with the default value, so I can do array repeating and creating an array by adding two arrays together. Okay, I can do a plus, creating an array with an array literal. So yeah, I can pass these values. Accessing and modifying an array. Modifying an array sounds pretty weird. I wonder if the arrays iterating over an array. So I've got for item in shopping list and then print item. Okay. I can also have sets. Okay. Hash value for set type. The type must be hashable in order to be stored in the set. So all of Swift's basic types are hashable by default and can be used as set values. Okay. I wonder if there are best practices regarding hashable, if like they provide because like for example in Java we've got in Lombok we have the at symbol hash code, I believe, is the name, and that generates a hash code directly from us. And I wonder if there is something similar in Swift. That would be useful. Creating a set with an array role, yeah, okay. Accessing and modifying a set Do they mention about creating and initializing? They don't. Never mind, not a big deal. We've got iterating, so that's the same thing as the other one. Performing set operations, so that is where I can do intersections, symmetric difference, union, subtracting. Cool. That is interesting. Okay, dictionaries. So dictionaries are the same as my maps. I've got int, string, so that is a key. Okay. Let's see, control flow. So control flow, I would expect it. So we've got the for in loops. Yeah, that seems very standard. I mean, for a modern. Okay, use the half open range operator to include the lower bound but not the upper bound. Okay, so for tick mark in. Okay, that is interesting. If I need to get to work with range operators, that is good to know. Some user might want fewer ticks marks in the UI. Every 5 minutes. Instead, use the stride to skip the unwanted marks. There is a while, so while condition and then statement. Okay. Repeat while. Okay, that's the same as a while, but with a while at the end. We've got ifs. Okay, why not? If else. Do they? Oh yes, they have a switch. Okay, so the switch, they have respond to value 1, case value 2, value 3, respond to value 2 or 3. Okay, so we don't have fall through in Swift as we do in C or even in Java. So switch the value to consider, then the case with the first value. So some value to consider is probably going to be some variable, and here some constant or more or less constant, and then default. Okay, good. So if I have some character, so here as we say that's a variable, and the value, then z, and some other characters. Okay. So there is no implicit fall through. Good to know. Very good to know. So instead, the entire switch statement finishes its execution as soon as the first matching switch case is completed. Yeah, this makes the switch statement safer and easier to use than the one in C. I do agree with that. I mean, the one in C can be nice, but it's so easy to shoot yourself in the foot. Invalid, the case has an empty body. Yeah. Okay, and then we've got interval matching. So if we can have some interval. Oh, they have tuples. I like that. I really like tuples. Value binding. So switch case can name the value of values it matches. Okay, so here, for example, we've got let x. So we define a new variable x and we use it afterwards in here. Yeah, cool. And the switch case can use a where clause to check for an additional condition. So case let x y, where x equals y. Okay. Yeah. So here that's very similar to the pattern. Well, not really pattern matching, but yeah. That is really interesting. Okay. So compound case, multiple switch case that share the same body can be combined by writing several patterns after case. Okay, yeah, that is interesting. And we can also combine these. Control, yeah, okay, so this is probably not something I'm going to use very often, but we have a throw here indicates that we can have, yeah, propagating errors using throwing functions. So in other words, exceptions. Okay, let's talk about functions. So functions, they have a func, they have a name, we pass arguments, and an arrow indicating the value that gets returned. Yeah, easy. Where there are some surprises because of the, let's see, functions with multiple parameters without return values. Okay. Functions with multiple return values. You can use a tuple. Yeah, okay, so we're not returning multiple return values. We are just returning a tuple that contains these information. That makes sense. That's an optional tuple return types. Okay, what does it mean? If the tuple type to be returned from a function has the potential to have no value, you can use an optional tuple. Okay. So we need to put a question mark at the end. It's different from a tuple that contains optional types such as int. So here, that means that the whole thing can be empty, while here, the first one could be empty, or the second one could be empty. Makes sense. Okay. I wonder about. So that's the Swift turn, and let's review. That must be in the basics about optional values. There is something I would like to check with optional values. So constants and variables, type annotation, naming constants and variables, printing constants and variables, commands, semicolon, integers, floating point numbers, type safety and type inference. Okay, where is, so numeric type, where is it? Integer and floating point conversion, type aliases, and that will be useful when we get a bit more funky. Booleans, tuples, so we already saw optionals. Okay, so the example below uses the initializer to try and convert a string into an integer. So we've got a string 1, 2, 3, and we've got this impossible number, and so converted number is inferred to be a type int question mark. Good, yes. So question mark indicates that we may have a null or nil value. Okay, so an optional int is written as int question mark, not int. The question mark indicates that the value it contains is optional. Good, meaning that it might contain some int value or might contain no value at all. Yes. Okay, so nil. How do we handle nil? You set an optional variable to a valueless state by assigning the special value nil. Okay. If you define an optional value, okay, without providing a default value, the variable is automatically set to nil for you. If statements enforced unwrapping. Okay. If an optional has a value, it is considered to not be equal to nil. So this should work. Once you're sure that the optional does contain a value, you can access its underlying value by adding an exclamation mark to the end of the optional name. So that is what they are doing here. The exclamation point effectively says, I know that this optional definitely has a value, please use it. This is known as forced unwrapping of the optional value. Optional binding. Okay. You can use optional binding to find out whether an optional contains a value, and if so, to make that value available as a temporary constant or variable. Okay, so we've got this if let constant name. So the constant name is what I'm going to use in here in the if, and that is the optional. Okay, so here actual number is if I have something in possible number, then I can use it here. And here the string possible number. No, okay, actual number is this, and this one doesn't have. Okay, that's I get it. I get it. So if let first number, and okay, so we can chain them. We can have if let first number, second number, first number, da da da. We can print this. Okay. Implicitly unwrapped optionals. Optionals indicate that a constant of variables is allowed to have no value. Optionals can be checked with an if statement. So let's see. Sometimes it's clear from a program structure that an optional value will always have a value after that value is first set. In this case, implicitly unwrapped optionals. You write an implicit by placing an exclamation mark rather than a question mark. So let's see. I have possible string, and here I've got my thing. Then I have this. I'm not sure I understand that. Yeah, let's see. You can think of an implicitly unwrapped optional as giving permission for the optional to be forced unwrapped if needed. When you use an implicitly unwrapped optional value, Swift first tries to use it as an ordinary optional value. If it can't be used as an optional, Swift force unwraps the value. I'm not sure I get it. Okay, so yeah, and we've got error handling. So don't use an implicitly unwrapped optional when there is a possibility of a variable becoming nil at a later point. Always use a normal optional type if you need to check for nil value during the lifetime of a variable. Okay. I'm trying to understand this. So if assumed string different from nil, print assumed string. And I really don't get it. Okay, so here I wonder if I can do. Let's try that. And let's give it a try. So I'm gonna reuse this example and modify it a tiny bit. Okay, so I am. Come on. So let's copy this. So I've got let possible string, an optional string. So that is gonna work. This one, can I do that? Equals possible string. So here I am saying I am getting an optional string, but I'm forcing it to be a string. And that is why I can do that. So is it going to work? I mean, I can understand why you would like to do that, but that is so dangerous. Okay. But what happens if I pass a nil value then? Let's try that. Okay, yeah. Unexpectedly found nil while implicitly unwrapping an optional value. Okay, and that gets caught during compilation time. That's okay. That is good. That is good. Because I don't want to have potentially nil values being returned and suddenly out of nowhere be getting. I am expecting a string, not an optional string, and then suddenly everything just explodes everywhere. All right. I wonder how far we can get in there. All right. So let's create a function. My function like this. Doesn't take any arguments, and that is going to return a string, an optional string. And here I am just going to do a return nil. I've got my return nil. Now I'm calling my function and I'm assigning it to possible strings, so that should work. And here I am going to try that. Is it? How deep does it go? Does it go? Oh, nice. So I indeed can have some nil value and extract it. Okay, okay. That is okay. And all right. So I have this. I have that. Let's continue. So I have some functions. Let's talk about closures. So closures are self-contained blocks of functionality. That's kind of, think of it, for those of you who are not familiar with it, think of closures as functions without a name. Okay, so closure expressions, nested functions, okay, sorted methods. And then I have this, okay, closure expression syntax. So I pass the parameters. Okay, so here I have the signature of the closure, which is almost the same as the signature of my methods, except that I don't have any name for the method. And then and then I pass the statements. Okay, I wonder if my statements must be, if I have multiple lines, do I have to wrap them around in curly braces or not? Maybe they have some example. They don't. So it automatically provides shorthand arguments names to inline closures. So we can refer to the values of the closure arguments by the name $1, $2, $1, $2, and so on. Okay, that's much better than the underscore in Scala. I really like that. So here's name sorted by, and then I can just, this here is a closure. I don't need to have the whole thing. That is super cool. And there is actually an even shorter way to write the closure expression. Okay, if I just pass the operator. Wow. Impressive. Okay, so some function that takes a closure, so that is the closure in question. Some function that takes a closure, I can also pass the body of the closure here. Some function that takes a closure. Okay. That is interesting. Okay, digits. So here I've got a number, so that takes a number as input and returns a string. I don't need to indicate an in, and everything here is, okay, so that's a multi-line closure. Good. So I've got number equals number, val output equals an empty string, and then I repeat when the number is bigger than 0. And yeah, okay, so, okay. Good. So the next things I am going to be interested in are enumerations, structures and classes. I think that properties methods should be the same. I'm kind of curious about subscripts and concurrency. Concurrency is so interesting to me. Okay, so enumerations. So I've got some enumeration and then I can pass. Okay, so a compass point can be either north, south, east, or west. So these are 4 different values. Or like planets in the solar system are these ones. Okay, so the type of directions to head is inferred, and once direction to head is declared as a compass point, you can set it as a different compass point value using a shorter dot syntax. Okay, so here that's enumeration name, well, the enumeration type, and the actual value in the enumeration. I can have matching enumeration values with a switch statement. Perfect. Iterating over enumeration cases. For some enumerations, it's useful to have a collection of all that enumeration cases. And we write this by writing case iterable after the enumeration names. Okay, so that creates an all cases property of the enumeration type. So I can get here all my cases. Cool. Associated value, okay. So products are labeled in 1D, So I can, okay, so here I've got an example, I've got a barcode, like, and it can be either a UPC or a QR code. If it is a UPC, I can have 4 integers. So 1, 2, 3, 4. Okay. If I've got a QR code, I'm getting a string out of it. So that would be here. Okay. Yeah, that is... Dang, I really like that. Okay. So enum as key control character. So let's see. As an alternative to associated values, animation cases can come pre-populated with default values called raw values, which are all of the same type. So ASCII control character, and I can have a case with tab, and I associate the value \t, line feed \n. Okay. Implicitly assign raw value. So Mercury is 1, and I don't indicate anything for the other planets. So Venus is going to be 2, 3, 4, and so on. What about compass points? When strings are used for raw values, the implicit value for each case is the text of that case's name. Okay, so here, let's try that. We're going to take our planets, and we're going to, so I have an enumeration of planets, and I am going to say that the associated value is going to be a string. And let's do a print of like Earth. So value for Earth is, and let's display that. Okay. Oh no, I need to pass planet.earth. Yeah, because otherwise it won't know what I'm talking about. Earth is not in the scope. So let's try to do that. Swift run everything, and value for earth is earth. Cool. All right. So that's what I am expecting as an explicit raw value of south and so on. You can access the raw value of an enumeration case with its raw value property. Cool. Initializing from a raw value. So this example identifies Uranus from its raw value of 7. So I can say the enumeration automatically receives an initializer that takes a value of the raw values type as a parameter called raw value and returns either an enumeration case or nil. So, okay, let's try that. So we are going to go back to int. Now that should be, so Mercury, Venus, Earth, so that would be, I think it's, the index is 0 by default, so Earth should be 2. So let's run this. No, that's not what I was expecting. Let's try again. Okay, nope, 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 nope. Let's surround it in like quotes. Maybe that will force the whole thing to be reloaded. And so value for earth is earth. Let's try a raw value then. Okay, so value for earth is 2. Oh, okay. Let's try to change it back to string then, because I guess I must have made a mistake before. So value for earth is earth. Okay. All right. So here I want to have let's planet, and I want to do a planet with raw value of 3, which should be the one after, which is Mars. Do I have, so that should return a planet, but is it a planet or a planet with a question mark? That's interesting. Okay, let's see. So I'm going to try that. I am forcing the type, and if the compiler is fine, it should tell me, nope, you are trying to cast a planet when you are actually getting an optional planet. Yes, 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 yes. Good. All right, so value of optional type planet question mark must be unwrapped to a value of type planet. Absolutely. Because, let's see. So value for Earth is 2. I'm going to just change this one to planet. Value for my planet is planet, like this, okay. And so now that should, okay, why is it not? Force unwrap must be unwrapped to refer to a member raw value. Okay, because raw value here, if it is a nil, I'm trying to call raw value belongs to planet, but not to optional of planet, which makes perfect sense, and that is beautiful. I really like that. Okay, so let's do that. If let's, I'm going to call this one planet OPT, and I'm going to use my planet here. So planet equal planet OPT. I'm going to pass this thing here. Okay. So now I've got my optional planet. If it is not null, then I pass it here, and that should work. Yeah, value for my planet is 3. Oh, cool. And what happens if I try to do... So I'm not going to call raw value because raw value is not part of planet of the planet enumeration, but I'm now calling planet OPT. So that should give me Mars. So let's try. So here value for my planet is optional, and then I pass Mars. Okay, so that really is that gets translated directly by the compiler into a method, into a class, I guess, called optional. So cool. So I still have warning. String interpolation produces a debug description for an optional value. Did you mean to make this explicit? Yes. Use string describing to silence this warning. Okay. Provide a default value to avoid this warning print. Okay, so yeah, the compiler notices this and complains about it. It says, "Hey, you're not doing something you're supposed to be doing." Cool. Okay. So I've got my enumerations. Next thing I want to do is in the classes. So there is a difference between structures and classes. Basically, classes have additional capabilities that structures don't have. So where is the where is it? Where is the explanation about what is a class and what is a structure? Basically, from what I remember, classes have references and structures have not. So structures are stored on the stack, I believe. Well, structures are on the stack and classes are on the heap or something like that. Okay. So inheritance enables one class to inherit the characteristics of another. So we can have inheritance with classes, but apparently not with structures. Typecasting enables you to check and interpret the type of a class instance at runtime. Deinitializers enable an instance of a class to free up any resources it has assigned, and reference counting allows more than one reference to a class instance. Okay. I am interested in knowing if I can iterate over the members of a class or a structure. And that is really more for meta programming more than anything else. So member-wise initializers for structure types, accessing properties, structures and enumerations are value types. Okay, they are value types, that is good to know. Classes are reference types. Yeah. Identity operator. So because classes are reference types, it's possible for multiple constants and variables to refer to the same single instance. So it can sometimes be useful to find out whether two constants or variables refer to exactly the same instance of a class. Okay, well, why not? And pointers. Okay, no more indications than this. Properties maybe. So stored property is a constant or variable that's stored as part of an instance of a particular class. Okay. Yeah. Stored properties. Yeah, no, I'm not that interested in that. What is subscript? Can define subscripts, which are shortcuts for accessing the member element of a collection list of sequence. You can use subscripts to set and retrieve values by index without needing separate methods for setting and retrieval. For example, you can access elements in an array instance as some array, an index, and elements in a dictionary instance. Okay, so that is similar to a get or a set. So I have subscripts enable you to query instance of a type by typing one or more values in square brackets after the instance name. Okay, the syntax is similar to both instances. You need subscribe with a subscript keyword and specify one or more input parameter and return type. So here subscript, I've got an index of type int and that returns an integer. So if I do a get, returns an appropriate subscript value here, and set, I can set a value. The type of new value is the same as the return value of subscript. So here that's going to be an integer because we are returning an integer. As with computed properties, you can choose not to specify the setter's new value parameter. A default parameter called new value is provided to your setter if you don't provide one yourself. As with read-only computed property, you can simplify the declaration of a read-only subscript by removing the get keyword and its braces. So okay, so I've got timetables. I've got here this. Okay, so if that is just giving me multiplier times index. So 6 times 3 is, and then I pass this, pass an integer, and that returns. Okay, so that is, I can't set the value, I just have a return. So that's why I've got a getter. Can I subscript usage? Okay, that is interesting. That is pretty nice. So optional chaining. So optional chaining, for those of you who are familiar with, are probably how you can do some monad chaining with optionals. So optional chainings as an alternative to forced unwrapping. So I have a person that could have a residence, and this residence is an optional, and it has a number of rooms. So residence instance have an integer. Okay, so I've got John, which is a person. And if you try to access the number of rooms property of this person's residence by placing an exclamation mark after residence, you trigger a runtime error because there is no residence value to unwrap. Okay. So I could do if let room count John residence question mark number of rooms, and then John's residence has room count of rooms, otherwise unable to retrieve the number of rooms. Okay. That is interesting. Defining model class for optional chaining. So I can have a subscript. Okay, the number of room is yada yada. So it has a variable property called rooms, which is initialized within an empty array of type room. Because this version of residence stores an array of rooms, its number of rooms property is implemented as a computed property, not as a stored property. And the computed number of rooms property simply returns the value of the count property. Okay. So how do I change that? Oh god, that is getting really, really complex. Accessing properties through optional chaining. Okay. Calling methods through optional chaining. Okay, let's leave it aside for a bit and think about concurrency. Oh, and they have opaque types. concurrency and then take a look at opaque types. So defining and calling asynchronous function. An asynchronous function is a special kind of function that can be suspended while it's partway through execution. So I have here a method called funcListPhotos, which takes a string and returns an array of string. Async, meaning that we could have some asynchronous code. All right. So for a function that is both asynchronous and throwing, you write async before throws. Okay. For example, the code below fetches the names of all the pictures in a gallery and shows the first picture. Asynchronous. Okay. So right now they mention how something could be asynchronous, but I want to see how do I do to get something asynchronous? So unstructured concurrency. So unlike tasks that are part of a task group, an unstructured task doesn't have a parent task. You have complete flexibility to manage unstructured tasks. Did I miss something? So calling asynchronous functions in parallel. So, for example, to fetch the first 3 photos from a gallery, you await 3 calls as follow. This approach has an important drawback. Although the download is asynchronous and lets other work happen while it progresses, only one call to download photo runs at a time. Okay, so yeah, I've got this one, then once it's complete, I've got that one and this one. So to call an asynchronous function and let it run in parallel with code around it, write async in front of let when you define a constant, and then write a wait each time you use the constant. Okay, yeah, so here I do this await download photo. So as I do that, I am blocking download photo. No one else can access it. Same thing here and same thing there. Here, on the contrary, I can run these ones separately. Okay, that is good. But that still doesn't tell me how can I spawn like a new thread or a new fiber or new something like this. Okay, so a task is a unit of work that can be run asynchronously as part of your program. All asynchronous code runs as part of some task. Async let syntax described in the previous section creates a child task for you. You can also create a task group and add a child task to that group. Tasks are arranged in a hierarchy. Each task in a task group has the same parent task, and each task can have child task. Why not? Because of the explicit relationship between task and task groups, this approach is called structured concurrency. So, so here they talk about that. Why not? In addition to the structured approach to concurrency, Swift also supports unstructured concurrency. So that is, okay, what they described here. We can have a task group and yeah, I guess I can investigate this later. So Swift, okay, so here I've got task, so I can create an explicit task. Okay. So here. Okay, and then I've got actors. Like classes, actors are reference types. So the comparison of value types and reference type in classes are reference types applies to actors as well as classes. Okay, so let's see. Can I do something like, okay, let's try that. So I've got my enums, and now so I want to do that. Okay, my async and await. So here I'm going to do two methods. One method that waits for print something, waits for 10 seconds, print something else. And then I have another method that is going to iterate a certain number of times, and let's say every second it will print something. So here, let's do that. Func of long running method. And this one doesn't return anything. So what it does is it's going to print something at the beginning. Let's do this long running method here. That, and I'm going to do, oopsie, Control C, Control V. So exit, and this one is going to be enter. And do I have, I don't know, something like sleep? No, I don't. Do I have something about threads? No. How do I do to sleep in Swift? Swift, sleep thread. Delay a function call and sleep a thread in there. Okay. Dispatch queue, sleep a thread for a number of seconds. Yeah, for a number of seconds. So I've got thread.sleep. Do I need to do an import or something at the beginning? I don't know. Let's try that. Okay. So I've got this long running method, and I'm going to do the same thing here. So the long running one is going to sleep for 10 seconds, and the short running, so let's rename this, it's going to be, okay, so it's going to sleep for 1 second. So right now I haven't put any async or any await. Everything is synchronous. So, okay, all right, so let's do that. I want to have, let's do this. Do I have the possibility to capture the time right now? In Java, that would be a system out. No. Console. Nope. Time. Nope. All right, let's see. So Swift get current time. There must be something super easy. So I've got time calendar.current. How do I get the current time? Update for Swift 3. Isn't there something a bit easier? I would expect it to be a one-liner. Dang it, that is complex. Okay, I want to have just the current time, let's say in milliseconds. Calendar.component, no. Wow. Well, I know that time is super hard in milliseconds. Let's try that. Okay, so milliseconds, return of self time interval since. Okay. Oh, there's this date, and that's okay. So that is extension time interval since times 1000. All right, right? So I can do date and time interval since 1970. All right, let's try that. Let's do func. Debug now. That's going to be a utility method that does a print of date like this. Dot. Oh, is it not working? Let's try. Let now equal date. Okay, and I want to do now dot. Is it not working? Do I need to do a, that was that. Let's try this. Control V. So now dot. Okay, first let's do a print, or let's call debug now and try to run this. So Swift run stream, it doesn't work. Cannot find date in scope and thread in scope. Okay, so I need, I guess, to do an import somewhere. Import foundation. Is it going to be enough? I think foundation is what needs the default package that we need. So let's see. Does it compile? It is taking a bit longer. I don't know if that is a good sign. So value of type as no member millisecond since 1970. Okay, so now it recognizes time, date. So do I have? Okay. Oh, maybe time intervals since 1970. Okay, let's see. Is it better now? It probably is. Ooh, okay, yeah, yeah. So that gives me a very precise time. And basically what I want is to have it multiplied by 1000 and then round it. Okay, good. So that is an extension. Interesting. So self time. Let's see. I've got an extension of date. So I'm extending date. I create that millisecond since 1970. That could even be a let instead of a var. I don't get it. So when I create it and I pass these milliseconds, then I do self equals date and I pass this time interval. Okay. So let's see. Let's see. Okay, so I have my date and I need to do so time interval since so the interval between the date object and okay, the properties value is negative if the object is earlier than midnight UTC on January 1st, 1970. Okay, that is what, but it doesn't tell me what that is. Is it a interval between the date object and midnight? But it doesn't tell me if this interval is, oh, time interval. Oh, okay. Okay, so let's do that. So now, so that is not as long as it is in Java, and that is the reason why I had some problems. That is a time interval, so there must be some method in here that gives me, I have now, or that is a time interval. And time interval is actually a double. Okay, yeah, I would like to know more about this. What is it? Okay, is it so Swift time interval? Do we have any documentation somewhere that explains what that is? So a time interval is always specified in seconds. It yields sub-millisecond precision over a range of 10,000 years. Alright, so if I want to have that a double, so I need to multiply it by 1000 to get in milliseconds and then round up. Okay, so now I'm getting it. So they time intervals times 1000, that gives me the value in, and I want to get it in 64. Okay, and the whole value must be rounded because I am not interested in, I think there are like nanoseconds and so on. So rounded like this. Cool. Cool. All right. So now debug, that should be more in line with what I am familiar with. No, convert value of type double to specified type in 64. Okay, so that is a double times an integer, so that gives me a double. Let's see, is it why they had put a dot? Let's go back to the example. So the example was serve.time interval times, yeah, and out rounded. So is it better? Can I convert a value type double? Maybe I need to force cast it to, yeah, so I guess I need to return, oh yeah, I need to force cast it to an int64. So int64 of this whole thing here. Yeah, that should be better. Okay, I'm a bit surprised. What is rounded doing? So rounded returns a double. Okay, and int64 is just, do I really need the rounded? I mean, let's see, let's try that, because if, yeah, that gives me something very similar. Rounded is not needed here. Int64 is going to round it for me. Okay, good. So now I can see, now I can get my, my different things. Okay. Instead of this debug now, what I'm going to do is this is going to return a string. Okay. And I need to do this now. Return now dot toString. Is there any? It's probably going to complain because I'm trying to return a So return expression of type int64 to return type string. Okay, I could do that, and that is going to return in a string, but is there any proper way? So let's do that. Oh, that doesn't even work. Cool. Let's see. Do I have anything in int64 dot string? No. I need something that returns, or maybe a string here, and then I'm going to pass now. Let's see, does it work? It does work. So I am explicitly taking a string and creating a string out of my int64. Good. All right, and now it complains because debug now is returning a value and I'm not using this value. So that's fair enough. Fair enough. So here I'm going to do, I'm just going to change this a bit. Instead of debug now, what I want to have now is going to be, it's going to take a string, so str string, and actually not return anything anymore, like that. So I have now, so what I want to do, I don't want to have this as an int64, I want to have it as a string. So string, oopsie, string like this, and I want to do that. Okay. So now what I want to do is I want to get, I want to do a print. I want to print on the screen the time it is now, plus some separator, and then my string. Cool. And I am just going to, I'm going to rename it with debug with time stamp. And I'm going to replace all the calls here with this method, so that I can get, whenever I'm calling long-running methods, I can get the timestamp associated with them. Okay, so I'm going to try to do now a call to long-running methods followed by a call. So let's do a for. Can I do a for let I in 0? How do I do ranges again? I think we saw ranges a few minutes ago. Where is it? Concurrency. That was at the beginning, I think. In control flow, I think. Yeah. In index. Okay. So I can have. So that goes from 1 to 5, and 5 included. So here I need 0 dot 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 10 like this, and I want to do short running methods every time. Why is it complaining? It's highlighted. Okay, I don't know why. Let's compile, and if there's an error, I will see why. Okay, so missing argument str in call. Oh, yeah. That should be a bit better. So let's try that again. Immutable value
underscore or removing it. And let pattern cannot appear in an already immutable context. Okay, yeah, why not? I just want to have it called 10 times. Okay, so it's going to wait for 10 seconds, then it will exit, and then for each second I will be getting a new short running method. Yeah. Cool. Okay, so that seems to be working the way it should. So now what I want is I want to change that so they become asynchronous. So func long running method, I'm going to put the async keyword here. Oh, shoot. I'm going to take this thing here and put that one there. Okay. So I've got async, and so now if I do an await before and await here, so I'm going to wait for that, and then I'm going to run it. Yeah, I think that's okay. Let's try this, and that should be doing the same thing as before. So async in a function that does not support concurrency. Okay. Async call in a function that does not support concurrency. Okay, maybe let's put it in a different function. So my func, like that. How do I, is there any way I can, okay, let's try to run this. Probably going to complain again. Yeah, add async to function my func to make it asynchronous. All right, so back to my concurrency. I need here to do something. If you return concurrency model in Swift is built on top of threads, but you don't interact with them directly. So I've got this func like that. The task.sleep method is useful when writing simple code to learn how concurrency work. Okay, so I'm just going to replace my thread.sleep with task.sleep. That is a bit, apparently that's a bit better. So let's already do that. So thread, change it to task. And change this one to task as well. Alright, so await task sleep, Here's a version of a list that uses sleep to simulate waiting on a network operation. So I await on that, and okay, so I need to indicate that I need to await. Okay, so await task sleep, and here await task sleep. Okay, so that is async, debug now with timestamp. So shoot. Okay. Okay, so I've got these await long running methods. So it is still going to complain. So I don't want my func to be asynchronous. I want things inside my func to be asynchronous. Asynchronous sequences for try wait line. task and task group. Unstructured type. Okay, actors. But why am I not able to So that is, I really like how easy that is so far, but this, I am not sure I understand async call in a function that does not support concurrency. Why? Okay, I don't want to make my func asynchronous. I want things inside to be asynchronous. So let's do a Control C and run a search on Google. How to fix, okay. When you've tried to call an async function from a synchronous function, which is not allowed in Swift, asynchronous functions must be able to suspend themselves and their callers, and synchronous functions simply do not know how to do that. If your asynchronous work needs to be waited for, you don't have much choice but to mark your current code as also being async so that you can use a wait as normal. However, sometimes this can result in a bit of an async infection. Yes. You mark one function as being async, which means its caller needs to be async too, okay. And so on until you've turned one error into 50. In this situation, you can create a dedicated task to solve the problem. Okay. So I need to wrap everything into a task. Gotcha. All right. So here, task like that, and this. Okay. So now that everything has been wrapped into a task, it should be much better. Okay, external document label 4-time interval in core. Oh, I don't need to pass this. Fair enough. Okay. Is it gonna work now? Okay. Okay, so I know what happened. I am calling, oh, yeah. My func now, it was a method and I was never calling this method, so that's why everything compiles but it doesn't run. So let's try that again. Still nothing. Okay, so let's Control Z this guy and call my func explicitly. I have another idea why that doesn't work, and that could be because I am not, my func is the main method. So I run it, I create all my threads, but immediately after this, I just close everything. So I should have, maybe, is there any way I can do a console reads? Let's see. Swift console reads. So yeah, now what I want to do is, okay, so we read the name from the user and read line. Okay. So here I am going to call my func, and read line is going to block until I am getting some value. So hopefully, if I press any key, that should close the app directly, giving the time for the task in the background to execute. So let's try that. That is here, Swift run stream. Yes. So now what I have is is I have long-running method enter, exit. That was very fast. The result of call, yeah, it's unused. I don't have any problem with that. Long-running method enter and exit. But I put in a wait here, so I should be getting, you know what, let's go back to my thread.sleep instead. Thread.sleep, full time interval, and we were using 10. I'm sure that there is a way to do that properly with the task.sleep. I just want to test my stuff first, so for time, so sleep, so, oh no, that's a thread dot sleep full time interval, and the short running one is 1 second. So hopefully this time that should work a bit better. Okay. So the long running method, we are waiting a long time, so 10 seconds. Yes, 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 yes. Okay, so I am getting this. So the problem I have is that they are not running in parallel. I want them to run in parallel. So I'm going to create an async long R like this, and let async, or async let. I think it's async let, okay. And then I want to create a list. So that what this is going to do is I want to have an array like this dot fill. No. How is it called? To create array dot. I want to have a value, and then I want to. Where is it? Index init. Init sounds good. So init repeating, and I pass a value, and then count. Okay. So repeating. So I want to call short running methods, I guess, and count 10 times. And let's do a let short equal so what this on 65, what I think I'm doing is I am starting my async thread, then I am doing this. Okay, I guess I can do for underscore in 0, 10, and then I can call my short running method and do an await before, like that, and then I can do await of long R, like that. Yeah, I think that should work. Okay, so let's try this. And now I should be getting my long, and the long should be about to the beginning. So I see here I've got long running method, short running method, enter, exit, enter, exit, enter, exit. And I am exiting my long running method shortly before these. Nice. Okay, I get it now. That is super nice. I really like that. Okay, and I can also have actors as well. Wow, Swift is really getting better and better. So concurrency, we've got typecasting, nested types. Let's take a look at opaque types. Is it? Okay, so for example, suppose you're writing a module that draws ASCII part shapes. So the basic characteristic is you've got a draw, which you can use as a requirement for the shape protocol. You can use generics to implement operations like flipping a shape. The flipped result exposes the exact generic types that were used to create it. So I take a shape and I return a shape. This approach to defining a joint shaped structure that joins two shapes together vertically, like the code below shows, results in types like joint shaped, flipped shaped triangle, triangle from joining a flipped triangle with another triangle. Okay. Exposing detailed information about the creation of a shape allows types that aren't meant to be part of the ASCII art module's public interface to leak out because of the need to state the full return type. The code inside the module could build up the same shape in a variety of ways, and other code outside the module that uses the shape shouldn't have to account for the implementation details. Okay. The module's public interface consists of operations like joining and flipping a shape, and those operations return another shape. So you can think of an opaque type like being the reverse of a generic type. Generic types let the code that calls a function pick the type for their function parameters and return value in a way that abstracts it away from the function implementation. Okay, so here the type that depends on its caller. So T, where T is a comparable, meaning that I can compare these two. The code that calls max chooses the value for x and y, and the type of those values determines the concrete type of T. Those roles are reversed for a function with an opaque return type. An opaque type lets the function implementation pick the type for the value it returns in a way that's abstracted away from the code that calls the function. For example, the function in the following example returns a trapezoid without exposing the underlying shape type of that shape. So I have square, which is a shape, and it has a size, and we can draw it. And here we have make trapezoid of some shape. Okay. So that returns the shape. Okay. You can also combine opaque return types with generics. I see this sum here is some way to to return an opaque type. So we've got the where sum some shape. Okay, yeah, I guess that it must be a reference to the opaque type. Okay, so if shape is square, return shape, error returns so func draw. So if shape of type T is a square, then I draw. I could do shape draw, let, and then otherwise I try to draw and split with the line return and return lines reversed and joined. Okay, so here that returns a shape. So I take T and return a shape. Okay, yeah, no, I think I'm getting it. I doubt I will need it yet, but I think I'm getting it. Okay. Oh, that is interesting. Okay, so I am going to make a quick break. And then after this, I'm going to take a look at Vapor, which I've heard is the library to be used if we want to work with Swift in creating web-based applications. So yeah, talk to you in a bit. Hi again, everyone. So let me switch my scene. Yeah. So yeah, I was taking a look at everything so far. So that was a quick recap for me about Swift. I haven't touched that in probably months now. I believe the last time I touched Swift was last year. But I took a look at what they did about concurrency with the async await, and I am amazed by how good that is. So that is really, really sweet. I really love that a lot. So now the next thing I want to do is I've heard about Vapor, and I am going to take a look at Vapor. Maybe we can create some kind of a web app or something. Very quick web app to see how Vapor is working. So let's have a look at it. So let's first start with doing a quick search. Do we dot vapor.com. Oh no, google.com. I have seriously doubt that vapor.com redirects to that. Okay, so here what I am interesting. Uh, okay, so I am gonna run a search for Vapor Swift. Cool. So vapor.codes. Yeah, that sounds right. So here, a new type of web framework. So I can do this import vapor, let app equal try application dot detect. Okay, defer app shutdown, app get hello. So if I do a get on hello, then I return hello world and then try app run. Okay, is that it? That seems super easy. Okay, let's do it. Get started. So getting started, if this is your first time using Vapor, head to install macOS to install Swift and Vapor. Once you have Vapor installed, check out Getting Started Hello World. Yeah, I want to install it, but can't I do that with a Docker image instead? So supported distribution and versions, install Swift, Docker. Nice. You can also use Swift's official Docker images, which come with the compiler pre-installed and more at Docker's Docker Hub. Okay, so now that you have Swift installed, let's install the Vapor Toolbox. This command line interface tool is not required to use Vapor, but it includes helpful utilities. On Linux, you will need to build the toolbox from source. View the toolbox releases on GitHub to find the latest version. So I need to do a Git clone of the toolbox, then cd toolbox, git checkout of the version and make install, and double check the installation was successful by printing help vapor --help. So I guess that I will need to take this. I'm going to take that. And I am just going to modify. So let's go back to VS Code. I am going to modify. There was in my dev container, I had this Docker file, and I will need to do something about it. So git clone, cd toolbox, git checkout. So yeah, first of all, let's take a look at the desired versions. So toolbox releases, and so I've got 18.33, I think is the one. So let's try that. Control V. Okay, so in this Docker file, I will probably need to, there is a syntax to run that. So let's do a quick search on Docker image creation. There must be something, create a base image, yeah. So create a full image using tar. So from scratch and then add, okay, parents. There must be something, so from copy run, so I need to do this run. Okay, so let's do that. Run, git clone, then I'm going to put an and cd toolbox and git checkout 1833 and make install. Okay, let's save. You want to install the recommended extension for Docker? Oh yeah, sure. Okay, good. So I'm gonna try to. Do I need to? Where is it? Oh yeah. So dev container Swift rebuild container. Hopefully that should rebuild everything with the new call to. So starting dev container show log. Okay. So run git clone. Okay, so cloning into Toolbox. Everything seems to be working. Yay. Fetching. That is good. Everything so far seems to be doing good. Okay, so let's wait for the Docker image to be created. And once it has been created, then I should be able to type the command indicated. So I think that was vape dash dash version or something like that. But I have to say, I really, really like the fact that we can run everything for Swift in a Docker image, which allows me to work on my PC without any problem. I mean, again, I do have a Mac, even many Macs, but this PC, the one I'm using here, is definitely a Windows machine with a lot of Linux stuff, but still a Windows machine, and that is super nice that I can run Docker images and get everything to work for me. So it is taking some time, but at the same time, I'm downloading everything, compiling stuff, so that is interesting. Incremental compilation has been disabled, not compatible with whole module optimization. Okay, fair enough. Compiling console git, okay. It is doing stuff. If it really takes a long time, what I could do is probably create an image and then call this image, store it somewhere, and then call this image instead of recreating the whole thing again and again. That would be a bit faster to just get this image, but that will be something for another time. Ooh, there was a problem. Okay, so let's see. So there was here raise the top level build shell error current stack trace. Yeah, that doesn't mean anything to me. Executable failed running bin sh and then c git clone make install exit code 2. I have no idea what an exit code 2 is. Let's scroll and try to see. So there was an error, Swift version 551, while evaluating request on SIL while running pass, tag dump without symbol names. Okay, let's go back up. So compiling NIO core addressed envelope.swift, incremental compilation, and compile zero idea what a signal 6 is. Okay, could it be a problem? So compile command failed to signal 6, use -b to see invocation, Swift runtime, what's the Swift 5.5 package, Linux Ubuntu, Swift Linux, yeah, .cpp, ooh, C++, okay, alright, so let's go and reopen the Docker file again. Where is that? Explorer. Was that the Explorer? Yeah, I think it was. Okay, I've got this disconnect. Okay, let me reopen that from here. So vi dot dev container, and I was interested in Docker file. And let's see, git checkout. So instead of 18.3.3, let's see, maybe with a version a bit sort of fixed default branch name, branch use from master to main, not a big thing. So yeah, that seems to be Tim who did that. So 18.3.2. All right, so let's no, that was yeah. So let's change 3 to 2. Save this guy and try to rebuild container. Hopefully this time that should work. And let's display here. Yeah, so the problem is we need to fetch everything again and again, so that is taking a long time. Especially if it is relatively big. Anyway, so let's wait again. Earlier it took about 2 minutes to, well, maybe more, 3 minutes I think, to get everything running. Well, to not everything running. I shouldn't say that. We we had no problem at the end. So maybe I can't open it in a dark image. I don't know. We'll see. So okay, it is taking some time. Well, okay, making some progress, I guess. So compiling neocore addressed envelope.swift, that is where we had a problem earlier. Yeah, and that happens again. Is it the same thing? So compiling yams, constructor Swift. Oh, that's a different one. And warning. Okay, so this is a warning. That's our addressed envelope Swift. And that is again So I think that is... Okay, compile command failed due to signal 6. So again, Swift front-end. So anonymous namespace, function info, Swift color analysis, unsafe get function info. Huh. And then we've got a stack dump, version Swift 551, while evaluating requests. Okay. Okay, let's go and take a look at Vapor. Maybe they have some issues, reported issues. So, command line, exec function crash on whistle, Xcode playgrounds preparation script, automatic. Okay. Let's maybe copy the error message and run a search on that. So what is the error message? I'm gonna try this. Okay, Control C, and let's go to Google again. So command failed due to signal. Okay. Let's keep the exact message, but I want to see if anyone had some problems with Vapor. Okay, so Vapor 245 doesn't compile. 245, that's a bit old. Trying to compile 245 with Swift 4.2. Okay, so that is already 4 years old. And okay, yeah. So apparently I don't think they ever had any answer to that question. Okay, let's switch gears then. If my I'm gonna go back to this thing. I'm gonna copy the whole line, delete it, and I should be able to recreate, so rebuild my container. That should work much better now. And maybe I can just open a shell script and try to run that from the shell script. Hopefully that should help me with what I have. So okay, so everything seems to be loading. Okay, installing. Good. That seems to be working. Okay, let's do a Swift dash version like this and 551. So I am back, and I am back. This is a Linux box. Good. All right, so I've got my Swift, I've got my Linux box. Next thing I want to do is I want to run the same command, so one after the other. let's do that. Where is, okay, so I'm gonna do this thing first. So downloading everything. Okay, so this succeeded. So the next thing I want to do is cd toolbox. Okay. Then I needed to do a git checkout of the desired version. So git checkout of 18.3.2, I think, or maybe no checking out 18.3.2. You want to take okay, and make install. Make install. So this is where everything is probably going to fail. Let's cross fingers. So creating copy, so far so good. Again, it's we are doing now step by step the same thing as what the doc image should be doing. Trying to figure out what the problem is. I'm wondering, is it a Docker problem or is it a problem with, well, Docker creation problem, I should say, or is it a problem with the make? I suspect it to be a problem with the make, but I want to be sure about it. So that's why I'm trying to run that again and trying to see what kind of result I'm getting. Okay, compiling stuff, computation's good. Compiling logging, okay. That wasn't here that I was getting any problems, so that should take some time, but should eventually succeed. Yeah, okay, console kit, activity bar Swift, so this one was succeeding as well. Okay. Compiling neocore. Yeah, that's where I am getting problems. So, huh, I am. So it is failing, but I don't. Am I getting the same mistake as before? I don't think I am. Well, the error looks very similar. Caller analysis CPP, and I don't see any mentions of my envelope anymore, but caller analysis CPP and line 237. All right, let's take a look. That was on home. have a Docker file. Oh, that is interesting. So they do have a Docker file that I could maybe use. And this, but it is using Swift 5.2, and I won't, because I like all my async awaits. I want to be using async awaits. So do I want to? Let's think about it. Do I want to use that? I mean, I could try to use that. Yeah, that is interesting. So from and then I've got this Swift build, and I pass the build. I am going to try to run this because that might be a problem between Swift 5.5 and Vapor. So let's see. Maybe that is reported somewhere on the Vapor side. So learn, get bug, So this is documentation for Vapor. Getting started. Install macOS. Okay, Swift version. So you should see version printed. Swift 5.2 or greater. Well, 5.5 is supposed to be greater. Not to worry. Is there anything version? So we've got 1.5.2.3.4 upgrading. Nope. Huh. Nope, nope, nope. Okay, so nothing obvious about 5.5.1. Let's try to use this. Yeah, I'm gonna try to use this as my Docker file instead of the other one. So dev container Docker file, and instead of using from Swift latest, I'm gonna try that. Control S to save everything, and then rebuild container. So hopefully that should work. And if that doesn't work, then we can see what the error is. If it works, then I am going to try to modify. I'm going to try to modify and get instead the. So if it works, I'm going to try and use 5.5 instead of 5.2. And if it doesn't work, then there were two parts in the Docker file for this. So I'm going to try and use the Docker file. Oh, but no, that's not going to work. That is not going to work because I have some problems here. It is referencing things that do not exist in this project. I should be adding some. Okay, let's wait for everything to crash first. Because this Docker file, the Docker file from, and let's take a look at Vapor. So I am on Vapor, yeah. Oh no, Toolbox. Okay, where is Toolbox? No, that's not what I wanted. Okay, Toolbox, yeah. So in this Docker file, I need to have the work there build. And then, so build is probably, oh no, it's not, it doesn't seem to be in here. Okay, why not? Copy. Okay, so yeah, I need to copy everything from the folder to build, and then I want to try to do this Swift build thing. Yeah, it's probably not going to work. But that is a good pointer for me. So let's wait for this to complete and crash, because it is going to crash. So I'm going to reference things that do not exist. It is taking some time. Extracting the 5.2 library. It's probably going to take a lot of time. Yeah. Yes, and indeed it failed on the copy part because, well, copy dot, there is nothing, but after this, I am trying to run stuff from this build thing, which does not exist. Root manifest not found. So yeah, that is indeed a problem. So okay, so yeah, let's switch gears. I am going to go and create, so here cd dot dot. I am going to create a vapor folder, and as we said, where is it? So where is the install documentation again? Oh, there it is. Linux. You can also Swift, learn and Swift's Docker Hub. No, that's the Swift Docker Hub. Okay, so let's copy everything here. So Git Clone here. Okay, cd toolbox, git checkout 1833. And instead of do a make install, what I want to do is a Docker build. Let's try. Is it Docker build? No. Docker build path, build an image from a Docker file. Okay, so Docker build. Is there no? Oh, maybe Docker build. Let's do cd dot dot then. Docker build. Is there no Docker file? Oh. Okay. rm -rf. Already I was not in the proper location. Okay, so cd vapor. Okay. So as I said, I want to do a git clone. Okay, cd toolbox. So now I can see my Docker file. So I should be able, let's do a git checkout 1833. I still have Docker file, so Docker build, Docker file like this. Yeah. Load build definition from Docker file, transferring loader. Failed to solve with frontend docker.b0. Failed to read Docker file error from sender. Warp Docker file not to directory. What does it mean? Okay, Docker file, okay, let's try to do a dot slash. Yeah. Okay, so Docker build needs needs a directory and not a file. Fair enough. So I'm just going to interrupt that for a second because I want to save this as an image that I can use afterwards. So let's go back to the Docker build command. I want to see the documentation to say, okay, save that as a, so Docker build option path URL. So Docker build, I can indicate that. Where is text file option? So cache from, compress. Where is the output? No. Is there anything about the name of the image? So build with path, build with URL, Docker ignore, tag an image. This will build like the previous example, but it will then tag the resulting image. The repository name will be via Apache, and the tag will be 2.0. Okay, I guess I can try that. I can try that. Okay. So that dash T for tag, and I'm gonna call it vapor and latest, like that. So hopefully what it should do is that it is gonna create an image called vapor with the tag latest locally on my machine. And if that works, then in that case, I will see if I can reuse it in my Visual Studio Code. So, okay, things are running. I think Visual Studio is having some problems. Not to worry about it, I can modify it afterwards. Actually, let's no. Let's wait for this to complete. I don't want to do like hundreds of things at the same time. I want to make sure that everything works fine. Okay. Just out of curiosity, I just want to go back and take a look at the content of the Docker file. So I have that is to build and that is to run, and then I call vapor. Okay. I don't know which one. I would expect that one to be the one that I am gonna tag, but let's wait for everything to complete and give it a try. So this one, build path build. Okay, so right now I'm working on the build. The other one completed. core seems to be working. Neo embedded as well. Oh, it is doing this right now. Okay. It is taking time. Neo exports. I don't think we ever managed to get there. I see this new POSIX BSD socket API comment, and yeah, that doesn't ring a bell. That is brand new. Cool. All right. So let's have a look, and I'm gonna use the Docker desktop. So images, and in images, I have Vapor here. Let's sort by. Do I have a possibility to sort by when it was created? So less than a minute ago. So I've got Swift, and I've got this Vapor here that was created. Okay, okay. All right. Let's see. Can I use Vapor as my base for my so vi dot slash what was the name again? Stream dot build, and I had a Docker file, I think was the name. No. What was the name again? So stream. Let's go to stream. Dev container. Okay. So cd, let me go back here because I might need to use that. And I was doing a vi of stream dot dev container and then Dockerfile. And I wanted to delete these guys and instead replace it with where is it? This beautiful, beautiful thing. Okay, so that was here, and instead I want to use from and indicate what I want to use. So here I'm going to do from Vapor like this. Well, okay, I saved it. Let's try to rebuild my container. This time, maybe it is going to work. I'm going to display the logs. Container started. The only thing is, I don't think that there is a Docker that Swift is installed on this one. I guess I can see that. Let's try Swift dash version. Yeah, not command not found. So I am close, but still no cigar, not yet. But I'm getting there. Okay, is it running container? Yeah. Okay, so that is a good sign. So next step. Next step now. So I am able to get that. So I am just going to modify my Vapor container and try to recreate everything first I want to do a VI of Docker file. And I am going to use this one. So that is going to be the same. So here, as I don't want to use Slim, I want to use the Bionic. Also, let's see, in so Docker Swift official image. What is the 5.1? So we have 5.5.1 Bionic or 5.5 Bionic. Okay. And here that was 5.2 Bionic. So let's do 5.5 Bionic and 5.5 Bionic. Okay, so I'm going to try to recreate my paper image again. So that is going to take some time. Yeah, I think earlier it took some time, so let's wait a bit. Hopefully now we should have a few more things in cache, so it might go a bit faster, but not much. I'm just going to open the window because it's getting a bit warm here. It's beginning of the afternoon. I'll be right back. Okay, so still compiling. Incremental compilation has been disabled. All right. Earlier it took something like took a few minutes to get this to run. Address envelope. So our famous address envelope that was fading with the other one. New embedded. Okay. Is it gonna work? Yeah, it is. It seems to be working. We are one step further than what it used to be a few moments back. Okay. All right. Yeah. So let's do that. Dev container, rebuild container from paper, and this time when it opens, I should have both Vapor and Swift running. That would be sweet if that works. Okay. Is it working now? I'm gonna add a new, yeah, so I need to do Swift dash dash version. Okay, so I'm using, I do have Swift. And for Vapor, the way was Vapor dash dash help. So let's try that. Vapor dash dash help. Ooh, ooh, that is sweet. Cool, 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 cool. All right. So yeah, everything seems to be here. So let's should I clean things up? You know what? Yeah, I'm gonna save this because that was useful. I don't need factorial greeter, do I? That is, in any case, that is a git, so cd. All right. I think that initializes stuff for me, not a git repository. Okay, I thought it was. So let's delete Toolbox. I don't need Toolbox in this folder. Okay. Git init. Git status. So I need to add git add. I am going to add my dev container. Git ignore. VS Code, I don't need it. Let's add package.swift. Readme, even though I haven't touched it. Sources, tests, and that would be it. Git commit dash m, and that is my initial commit, like that. Cool. All right, so now I need to do a git checkout dash p vapor. So I am on the vapor branch, and now I can do a vapor new. So let's go and take a look at getting started, hello world. And I'm not going to go any further than hello world because I don't have any time left. But okay, so the end flag gives you a bare bones template by automatically answering no to all questions. I am still interested in what these questions are going to be. So I am going to still run vapor new hello without the dash n. Vapor new hello. Okay, so I can't find it here. Makes sense. I am not in the Docker. Here, though, vapor new hello. This one should work. Cloning template, sweet. Would you like to use Fluent? No. Would you like to use Leaf? No idea what that is. And a web framework for Swift. Project Hello has been created. Okay. So I have Hello here. I have my package. I have a Docker file. Whoa. Out. Oh, that is sweet. I get build image from Swift 554 core as built. Holy smoke, that is nice. And sources app run main.swift. So I've got try environment detect, try logging state bootstrap from the environment. application, I get my application from the environment, defer app shutdown, try configure app, and then app run. Okay, cool. Cool. And then I've got my routes. So if I do a get, I get a it works. Otherwise, if I do a get on /hello that replies hello world, configure Swift. Okay, so that is my configure, which I guess I am calling here. Okay. And my controllers, I don't have anything in the controllers just yet. So that is really simple. Build and run. So yeah, I don't have Xcode. I can do this Swift run. So I need to go into, okay, let's do that. So cd hello, and I'm going to do a Swift run. So it is trying to compile everything, I guess. Computing version for that, okay. So yeah, I think what it is doing is that the way I remember Swift doing things is it connects to GitHub and retrieves all the libraries directly from GitHub. So that's why it might be taking some time. Hopefully that should go faster next time. So let's wait. It's retrieving everything. Async Git, Swift server. Okay, Swift Neo, Vapor Multipod Kit, WebSocket Kit, okay. Yeah, it is really retrieving everything right now. I mean, fair enough. I might need it in the future. Async HTTP, okay. Creating working copy for HTTPS, okay. So that is looking good so far. I wonder if wget is installed on the Swift image. I mean, once this is complete, I can give it a try, because I haven't opened the ports yet for this doc image, so I can't do that from my machine yet. But I should be able to open the ports. Let's wait. So Swift crypto. Okay. Wow, that is really getting a lot of things. I really hope that only does that at the first time we run stuff. So I think it is compiling everything. Not 100% sure. Again, I'm not a Swift expert. I'm rediscovering it. Yeah, so build is containing everything. Let's see. So creating copy for Swift Neo. Yeah. Whoa, that is really taking a super long time. Come on, Beeper, wake up. I mean, I'm a Scala dev, so I'm not that surprised. But still, I would have expected everything to go a bit faster. But okay, fair enough. If you want to recompile everything from scratch, it's you do you. Huh. Oh, whoa. 909 libs to compile. Holy schmoly. Okay. I am just going to open a new terminal. Do I have wget? No, I don't. Do I have curl? No, I don't. Sudo apt get install wget. Okay. Apt get install. Okay. Where is wget? Does it have another name in Ubuntu? It's supposed to be in Ubuntu, I think. Ubuntu install wget. What is it? Log into the system. Yeah. Update the system. apt install wget. Okay, yeah, that sounds like what I did, I think. Okay, so apt install wget. Yeah, all right. I might need to change how I create that after. Okay, let me close that. Oopsie, exit. And I am still compiling stuff. Well, I'm two-thirds of the libraries have been compiled, so yeah. Way to go. Only 200 libs to compile, yeah. Yeah. And it keeps on increasing. That is scary. We went from 900 to 1024. Oh, for crying out loud. Come on. Come on. Are you bloody kidding me? Oh, for crying out loud. Getting there. I really hope it's not gonna take as much time later. You know, whenever I think we're getting there, it seems to be increasing. All right. Come on. Come on. You can do this. Oh, I didn't remember that it was taking so long the first time I tried that a year or so ago. Hmm. Okay. UHTTP. Ah. Did I finally find something that was taking longer to compile than Scala? Wow. All right. I'm getting close to twice the amount of libs that were initially defined. Uncommented is a file from public folder, app middleware use, file middleware, public directory. And where is the /public? So I have app run, but I don't have public. Hmm. Yeah. Okay. Fatal error, could not build C module C URL parser. Let's try that again. Hopefully this time I should get the same error but faster. Or at least that would be my expectation. And so could not build C module C URL parser. Interesting. So probably import C URL parser. Now, I wonder why I've got this problem. And I see that it's already past the time for me to leave. I've got something in about 20 minutes now. Yeah, I don't think I will be able to complete this. It's taking way too long for me. Okay, Not to worry. So I'm gonna stop the stream now. But already that was good. I rediscovered a bit about Swift. We're making some progress with it. Maybe next week we can continue with Swift and try to understand why um, why I'm not getting Vapor to run. It could just be something to do with the CURL parser library because I'm running it from a Docker image. So maybe I need to add this library somehow to the Docker image. But sorry, once I'm done with that, that should be okay. I should be able to get stuff running. Anyway, we'll see that next time. Oh, compiling run main Swift. Is it running now? The heck? Nah, it's not gonna work. Okay, yeah, it's taking some time. I don't know what it is doing. I still give myself 4 minutes and then I will stop the stream because I really need to go at 2:30 my time. Oh, it did start. Holy smoke. So build complete, server starting. Whoa. It did start. Okay, can I? That is exciting. Add ports. Let's say 9999. Oh no. Can I change that? Okay, no, that's not what I wanted to do. 8080. Okay, can I try to do that on localhost 8080 with nothing? It works. Whoa. I am impressed. Okay, God, I still have 2 minutes. 2 freaking minutes. It works. Hello, Twitch. Okay, okay. So Control C and Swift run. Please, 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 please run. That would be so sweet if that worked as well. I wonder why it's taking so long for it to run. Because it's not, it doesn't seem to be doing anything right now. Okay, so now it is compiling stuff, merging module. Come on. Oh, that is taking so long. I think I deactivated the antivirus, so that's probably not the antivirus. Maybe just the fact that I'm trying to run in a Docker image or something. In a Docker container, sorry. Okay, build complete, yes. All right, and now we should have it works. Hello, Twitch. Yes, awesome. Whew. All right, so right on time. So thanks everyone, everyone who joined. It was super nice, and I'm so nicely surprised to see that I am able to run Swift on my Windows PC. That is really impressive. Okay, so next time, I think we're going to investigate Vapor a bit more, and in the meantime, I'm probably going to have some time to work with this. It's really interesting. I'm very excited, and well, thanks again, everyone. Talk to you very soon. Have a good one. Cheers, bye.